Hey everybody, it's Bruce and the dog on the floor, and today we're going to be taking our Nerves project that has blinking LED lights. Well, right now we only have one LED light that we're working with, but it will eventually be a clock. But what we'd like to do before we get too much further is take this architecture that's going straight from the boundary to hardware through a library called circuits.gpio and add an adapter layer. And this adapter layer is going to have a couple of benefits. First, it's going to allow us to take a piece of code and make it act one way on hardware. For example, it turns LEDs on and off when we send it the on and off function. And we're going to make it operate another way when we put it in software. For example, if it's in development, we want it to log something. Or if it's in test, we want it to track the history of all the on and off messages that have been sent so far. So this adapter strategy is a common one that you'll see, and it's going to get us into a little bit of configuration, and it will add a little bit of complexity to our application, but it will make dealing with the whole Nerves project oh so much nicer, because we'll be able to think about things in the terms of a whole, and we'll be able to write one big common boundary layer that doesn't really care about where it's running. So that's the topic of this video, and we're ready to get started. Okay, it's time to turn this Blinky into a turbo Blinky. So let's fire up the editor. Okay, so I have the editor up, and what we have in this project so far, there's really not anything happening yet in the outer API. This is our API layer. We do have a boundary, and the boundary is really an LED. But you know, this isn't eventually going to be a great place for the boundary. What this is going to be is an adapter. And the reason is that the implementation of this file will change based on the environment that we're working on. So right now what's happening? Well, when we open it, we have this logger info, which is presumably more for a development environment. Once I'm working with hardware, there's the actual hardware implementation, and I really don't have anything that records history for more of a test-like implementation. So let's take this implementation and turn it into something called an adapter. And we're going to use an adapter pattern. So what we're going to do initially is to build an implementation in our module, and we're going to run the same file 3 different ways. We want to be able to run it in IEX or through scripting on the development server. And then we want to be able to run our tests on the development server, which is the host. And then we also want to be able to run it on embedded hardware. And so this is what that code looks like. So we're going to create a new folder, and everything, all our adapters, LED, how about LED? All of our adapters will go there. And so let's say that we're going to have 3 of them. So I've got one called dev.ex, and then I've got one called test.ex, and then I've got, let's open that up so we can see what's happening. And then let's have another one called embedded.ex. How about embed? I think I like that name better. Okay, so the development version is going to look a whole lot like our LED. So we're going to take this thing and we're going to steal this implementation, but this is going to be an LED adapter. Right, so that's just the camel case version of that. And it's still going to need the logger, but our development implementation is not going to need the GPIO at all. In fact, it doesn't need to do this work because there's no hardware to talk to on the development side. And so that's what our API is going to look like. We're just going to process the ring logger in the development mode. And I realized that this might seem like a lot of work to do on a single blinking LED, but really what we're after is not the LED, but the pattern that we use to develop the Nerve software. So we're going to do something similar on the embedded side, but this time we're going to take that implementation, and this is going to be an LED adapter, and this is going to be the test, or this is going to be the embedded implementation. And in this case, we don't really need the logger. I don't need to log what's happening here. I could, but I really want to illustrate the concept. And so that's going to be my embedded module. And then what does the test do? Also for the dev module, I probably want to track some things that are happening in my LED. So I'm going to have a struct. And let's see, what do we want in this struct? We want to know if this LED is on or off. We probably want to know the pin that it's related to. And so this is going to be a pin. We'll say it defaults to 0. And then we are probably going to want to have a state or lit. Is it lit? And we will default that to false. And that's probably enough information for now. We'll amend this a little bit with our test mode. But what I'd like to be able to do is interact with this a couple of times and then see, and then kind of read the state for the LED just by looking at the structure. So that's what we're going to do. And so what I'd like to do is take these 3 LEDs right here, and I'd like to use the map update syntax. It's going to add some error to that, and then I'm going to say, in this one, I'm going to say the pin is pin and lit, and then I might, for default, maybe we can pipe this to off to make sure that the LED starts in the off mode. So we turn every LED off when we open it. That sounds like a good idea to me. So this is going to be, both of these are going to set lit. On, we'll set it to true, and off, we'll set it to false. Okay, so that's my implementation. And here the toggle doesn't really change because it's using the interface on the LED. So this is really an LED state. This is going to return like an LED state, and that's cool. And so this is my basic LED adapter for development mode, right? And so what does that look like for test? For test, it's going to look pretty similar, isn't it? But I'm also going to track a history. And that's going to start like this. And here we're going to set the pin, and we're going to set the history for open, because we've already opened this thing, right? And then we're going to turn it off, but this will go ahead and write to the history. So the history is going to be the LED.history, but we're going to take that and we're going to pin the on or off to what's already there, right? So it's going to be on if it's in the on state, it's going to be off if it's in the off state. So all we're doing is we're building this history as we go of the test LED, right? And so the embedded, we're going to hardware. That's exactly what we want. For the development, we're going to the hardware. And you might ask, on the embedded side, why are we always returning the LED itself? Well, in this case, this is an API that follows a pattern that I like to use, which is constructor, reducer, converter, the CRC pattern. And in this case, we have a constructor where the first argument is an LED, and I return a transformed version of the same type, right? So then I'll be able to pipe these together. This is what I mean. Okay, so let's see what happens when we interact with these in IEX. So I'm going to say IEX mix, and this is probably not going to compile. Never does the first time. Yeah, so I didn't update the dev and the adapter, so that's test. Great, and we'll run this again. Oh, doesn't exist and is being expanded to LED. So that strikes me as wrong. So on line 7, on open, I've got a problem. And this is going to return, how about I return, really what I really want is struct like that, right? Because the struct is the default function in Elixir for creating a new struct. And I can pass it the key value pairs, but it will pick up the defaults for the ones that I don't already set up, which is great. So, so I need to do that there. And I also need to do that in the, so that's the test implementation. I also need to do that in the embedded or the dev implementation. So it's struct, and then I don't need this LED, but I do need to grab these two right here, and then I'm going to turn it off, which is great. So let's try that again. Okay, so an impressive bug density as usual. So undefined function LED. So I'm doing the same thing there. And so undefined function of LED was in the test. Yeah, and I just had not fixed that yet. So I had not saved that file. Okay, so now we can go ahead and say test is equal to, and I could say is equal to clock or blinky dot LED adapter dot test like that, and then I could say dev adapter is equal to, and then I could do the same thing here but pick up dev, and then I could say the embedded oh how about that? So I set them both there. So now I need to go back and set the dev adapter. Okay, so I think we're working now. So we could actually use the API in a pretty interesting way. So I could take this API and I can open it like this. I could say pin 26, and then I could say dev adapter dot open, right? And that's going to, and look, it's giving me a new LED. It's not lit, which is great. The pin is 26, which is the one that we opened. And then I can turn that on, dot on like that, which is great. And now it's lit. And what's interesting is I could do the same thing in the test adapter because it has the same interface, but it has a different implementation. So you could see that what I'm doing is I'm starting to track the history, right? So I've got the off and then open for the test adapter. What's interesting here? So let's see, I've got, oh yes. And so I've turned it on here. So I turned it off the first time in the history. And then when I turned it on, so it didn't pick up that on. So let's find out why. So in my test, yeah, so off, I appended off to the history, and on, I appended on to the history. What's going on here? So let's see what happens. Oh, so if I track that, I'm picking up this history, and then if I pipe it to, oh yeah, look at that dev adapter. So I want the test adapter. And I want to turn it on here. Yeah, okay. So now I'm tracking the history, starting with the tail side. and that's giving me a history as I go, which is pretty cool. So maybe one of the things that we want to do is add an additional function to our LED called history to the test. So these will actually satisfy the API for the behavior that we plan. And this one itself, what do we want to call this? History of an LED. And then all we want to do is do an enum.reverse on LED.history, right? Because what's happening is we're appending things to the head, and when we get the history, we want to check them at the tail. So let's save that much and let's recompile. And now I should be able to pipe that to test adapter.history like that. And yeah, then I say, then I can see the history. First it was opened, then it was turned off, and then it was turned on. And this type of strategy is going to make it really easy for us to build a common interface on top of something and test it to get this history, run development where I have the full logging. So I could do something like this, logger or ring logger dot attach, which means I want to start receiving the log messages, and then I want to go back in history and pick up those dev changes, right? So let's turn it off and on. Yeah, so I can see that I'm opening here, I can see that I'm turning off here, and I'm turning on, which is exactly what I expect. And if I pipe that to one more time, dot off, then then it turns off one more time. So that's working perfectly. And then if you check what's happening in the embed mode, so if I start this with the embed adapter and I open that, you can see that I'm working with a GPIO reference, right? And I can check, I could say circuits. So I could say, let's see, the LED is equal, or let's say the GPIO pin, because that's effectively what it is equal to V16. And I'm picking up this line right now. V is IX history to pick up that earlier line. And now I can say GP or circuits.GPIO.read, and I can read the GPIO pin like that. And it tells me that this is off, which is exactly what it should be. And so if I go back in history here and I say that now I want to turn it embedded adapter.on, so now I can read that same pin and it's on. So what we have here, you can see that we're working on this adapter pattern. And the next job that we have is to configure the pattern. So we're also going to clean up this architecture a little bit so that we use a little bit of configuration to establish the right adapter at the right time. And while we're at it, we're going to establish the right pins at the right time. And then we want a common interface around that adapter layer. So we're going to use something called a behavior. And then when we write our code, you'll be able to write type checked code to make sure that the adapter is working, which is and make sure that the adapter is type safe and actually compiles neatly with the other layers that depend on it. Like we're probably going to make a layer next that blinks an LED a number of times. And that's an excellent thing. This is Bruce and the dog on the floor for Groxio Learning.